Consider a star so powerful that its magnetic influence can rip atoms to shreds across millions of kilometers of space. This audio journey invites you to explore the profound depths of magnetars, which are among the universe's most compact and enigmatic objects, surpassed in density only by black holes. These are the remnants of dead stars that, rather than simply fading into darkness, evolve into unseen titans with the power to warp both matter and space-time itself.
So, what exactly is a magnetar? They belong to a unique category of neutron stars, which are born from the cataclysmic supernova explosion that marks the end of a massive star's existence. However, the path to becoming a magnetar is not one that every neutron star follows. The crucial distinction is found in their phenomenal magnetic fields, which can be up to 1 trillion times more potent than that of our own planet. To put this in perspective, while a compass on Earth reliably points north, a magnetar's field could alter a spaceship's trajectory from light years away. The role of magnetars in contemporary astrophysics is truly immense, as they provide us with insights that extend far beyond the life and death of stars. By studying these cosmic behemoths, we are compelled to challenge the very limits of physics as we currently understand it, re-examining our fundamental ideas about matter, energy, and the force of gravity. Their existence forces us to ask what new revelations about the fabric of the universe they might unlock. When you contemplate the cosmos, you might picture a silent, empty expanse, but that image is far from accurate. In truth, space is a dynamic arena, teeming with invisible yet constantly interacting forces and phenomena. Magnetars, with their colossal gravitational and magnetic pulls, reign over their cosmic territories like giants, profoundly affecting nearby stars and any potential planetary systems. This exploration naturally leads you to question how such objects come into being, and the answer is every bit as spectacular as the stars that create them. The process begins with a supernova explosion, an event so luminous it can momentarily outshine its entire galaxy. It is on this dramatic stage that these magnetic titans are forged, although only supernovae that satisfy a precise set of conditions will give rise to these exceptional celestial bodies. As we delve into the properties of magnetars, their sheer uniqueness becomes apparent. While most neutron stars possess powerful magnetic fields, magnetars represent an unparalleled extreme. This has a vast and powerful impact on the space surrounding them, resulting in explosive emissions of X-rays and gamma rays. These brilliant discharges are not only captivating to observe, but also serve as a direct window into the physical processes that unfold at the very edge of our cosmic understanding. It's also natural to wonder about how long magnetars exist. These objects do not last forever. Like the stars they once were, they follow a life cycle. For a magnetar, this cycle is remarkably short but incredibly intense, punctuated by spectacular displays that leave us contemplating how much longer we'll have the opportunity to witness these cosmic titans in action. Curiosity also extends to their prevalence within our own galaxy. Astronomers are working to map their locations and have determined that while magnetars are indeed rare, their presence plays a significant role in the overall structure of the Milky Way. Detecting them from thousands of light years away is another fascinating challenge, solved by modern technology and clever observational methods that capture their faint signals, which arrive as whispers carrying stories of their nature and behavior. Ultimately, magnetars are far more than just scientific curiosities. They stand as a powerful testament to the vastness and mystery of the universe. Each one holds secrets that could fundamentally alter our perception of the cosmos, forcing us to reconsider theories we once held as absolute. Exploring their world is like opening a doorway to an entirely new domain of knowledge, reminding us to keep asking questions and marveling at the grandeur of existence.
Our adventure is only just beginning.
So, what defines a magnetar? In simple terms, it is a specific type of neutron star, which itself is the incredibly dense core left behind after a massive star explodes in a supernova. The feature that truly distinguishes a magnetar, however, is its mind-bogglingly powerful magnetic field. If you think of a refrigerator magnet, a magnetar's field can be 1 billion times stronger, a cosmic supermagnet capable of influencing its surroundings over incredible distances. The formation of these objects is a story of cosmic extremes. When a giant star exhausts its fuel, its core collapses, creating a neutron star. But only a select few evolve into magnetars. The determining factors appear to be the star's rotational speed and the way it cools following the supernova. A rapid spin helps generate an intensifying magnetic dynamo, and if that field surpasses a critical threshold, a magnetar is born, possessing not only an enormous magnetic field, but also an exceptionally fast rotation, sometimes spinning multiple times every second. So, what makes the study of magnetars so crucial? The answer is quite straightforward. They provide us with a window into the physics of matter pushed to its absolute limits. Within these cosmic objects, the forces of gravity and magnetism are so powerful that they seriously test the boundaries of our current scientific knowledge, forcing us to reconsider what we thought we knew. Furthermore, magnetars are renowned for their incredible high-energy behavior. The emission of X-rays and gamma rays is a standard feature for these objects, driven by their staggeringly intense magnetic activity. The reason they radiate so powerfully is that a magnetar's magnetic field can unleash its energy in sudden, violent bursts, transforming them into some of the most luminous sources of X-rays and gamma rays we have ever observed in the cosmos. This means that magnetars are not just fascinating by their very nature, they are also indispensable to astronomy. Investigating them can offer vital clues about how stars evolve and how matter behaves under the most extreme conditions imaginable. The classification of magnetars depends on their specific properties, dividing them into rotational and field types. Rotational magnetars are characterized by rapid spinning and an immensely strong magnetic field, whereas field magnetars are less active rotationally, but can possess a magnetic field that is even more powerful. This variety in their attributes gives each magnetar a distinct character, almost as if everyone has its own unique cosmic personality. When we talk about magnetars, a natural question arises. How do scientists even find them? The method is quite exciting, as it involves using telescopes designed to detect the high-energy radiation they emit, such as X-rays. This radiation is so potent that we can register it from thousands of light-years away, enabling us to study these objects despite their vast distance from us. However, locating magnetars is not always a simple task because their activity can be sporadic. At times they shine with incredible brightness, while at other moments they seem to vanish entirely, which keeps astronomers in a state of constant watchfulness. Magnetars also give us the chance to probe the very limits of our understanding of physics. As we study how these objects engage with their cosmic surroundings, we witness phenomena never seen before. For instance, their powerful radiation can alter the interstellar medium that envelops them, generating immense shock waves and affecting other celestial bodies nearby. This serves as a powerful reminder of the deep interconnectedness of the universe, where an object so distant can still have a profound impact on its local environment. The life of a magnetar is not an eternal one. Although they can persist for thousands of years, their intense magnetic activity causes them to burn through their energy relatively quickly. Eventually, every magnetar is expected to meet its end, releasing a final, colossal burst of energy. This ultimate process is still a profound mystery that scientists are actively working to solve. Each new insight we gain about their life cycle brings us a step closer to comprehending the grand evolution of our universe. In the end, magnetars serve as a reminder of just how phenomenal the cosmos truly is. These objects don't just defy our grasp of physics. They also offer a glimpse into the extreme states of matter that exist far beyond our own planet. Each magnetar acts like a beacon shining in the vast emptiness of space, steering us toward a deeper knowledge of energy and matter in their most fundamental forms. As our exploration of these captivating objects continues, we learn that the universe holds far more wonder than we could ever have conceived. If you are enjoying this exploration of the universe and want to delve deeper into the mysteries of the cosmos, I encourage you to subscribe and activate notifications. Magnetars stand as one of the most compelling phenomena in the universe, and their creation is a genuinely astonishing process. To grasp how a magnetar is born, you first have to look at the powerful and magnificent life cycle of stars. When a truly massive star depletes its nuclear fuel, it is destined for a spectacular and unavoidable conclusion. Did you know that this final stage can lead to an explosion so brilliant it can momentarily outshine its entire home galaxy? This event is known as a supernova, and it marks the very first step in the birth of a magnetar. You can think of a supernova as the most spectacular fireworks show imaginable. In a matter of seconds, the star undergoes a violent collapse, forcefully expelling its outer layers deep into space. But what becomes of the star's core? This remnant, which endures the blast, caves in on itself under its own immense gravitational force. At this point, the internal pressure and temperature reach unimaginable extremes, setting off a cascade of incredible events. In this scenario, the core can be compressed into a neutron star, an object so incredibly dense that a mere teaspoon of its substance would weigh as much as an elephant. This is where the magic of magnetars truly begins, as not all neutron star cores are destined to become one. For this transformation to occur, a very precise set of conditions is required, with the magnetic field being the critical element. Picture every neutron star as a sphere of highly magnetic material. In the case of a magnetar, this magnet is unfathomably powerful. While an ordinary neutron star's magnetic field is already quite formidable, a magnetar's field can be 1,000 trillion times stronger. It is this extreme magnetism, resulting from a process known as dynamization, that makes magnetars so unique. During a magnetar's formation, the churning of hot plasma within the core, coupled with the gravitational collapse, generates a magnetic field that rapidly intensifies. What does this imply for the life of a magnetar? It means that, much like an exceptionally potent magnet, it casts an influence that reaches far beyond its own physical boundaries. Its magnetic field is capable of affecting everything in its vicinity, including the behavior of other stars and celestial objects nearby. So, how long does this creation process take? The actual formation of a magnetar is astronomically swift, yet the outcome is an object that can exist for millions of years. Throughout its existence, a magnetar will continue to evolve. As it radiates energy away, its magnetic field may gradually weaken, but not before it has left a permanent impression on its cosmic neighborhood. The circumstances that give rise to a magnetar are so particular that it's estimated only about 1 in every 10,000 neutron star cores will ever become one. Consider for a moment how uncommon these objects are in the immensity of space. The formation of each magnetar presents a compelling new case study for astrophysicists who are dedicated to unlocking the secrets they contain. This quest has also spurred scientists to create innovative technologies and new methods of observation, which not only enhance our comprehension of magnetars, but also broaden our knowledge of the cosmos itself. Every new piece of information we gather about them opens another door to fundamental questions about the laws of physics under the most severe conditions. So, you might ask why their formation should matter to us. The reason is that these celestial bodies are more than just cosmic curiosities. They offer vital clues about the monumental events that have sculpted our universe. Magnetars provide a unique window into the processes of stellar evolution and the intricate dynamics of galaxies, allowing us to peek into cosmic history with every observation. Their existence is a profound reminder of our own scale against the backdrop of the universe, yet it also stands as a testament to the staggering variety of phenomena that space can produce. Each magnetar serves as a beacon of knowledge, beckoning us to explore and comprehend the forces that govern our world and the universe beyond. When you gaze into the night sky, I want you to think about the incredible chain of events that led to the stars you see. Some of those distant lights could very well be the afterglow of supernova explosions that birthed these magnetic powerhouses. In a sense, they remind us of the sheer beauty and complexity of a universe that never ceases to astonish us with its wonders. While magnetars are undeniably marvels of the cosmos, it is their magnetic field that truly defies belief. Have you ever stopped to consider the ultimate potential strength of a magnetic field? Picture a common magnet you might have at home. It can easily pick up small metal items, and bringing it near your phone could cause some interference. But what if I told you that a magnetar possesses a magnetic field so potent it could literally wrench an object the size of a major city from space and pull it toward its surface? To put this into perspective, a magnetar's magnetic field is billions of times more powerful than any magnet created on Earth. The magnetic field of our own planet measures about 1 microtesla, whereas a magnetar's can surge to an astonishing 1,000 trillion Tesla. This figure is so colossal that it's nearly impossible for the human mind to grasp. You're trying to envision a magnetic force so overwhelming that it can actually destabilize the very structure of matter. This extreme magnetic field is remarkable not just for its sheer power, but also for the effects it produces. As a magnetar spins, its incredible magnetic field can unleash torrents of high-energy radiation. While other dense objects like black holes and neutron stars also possess magnetic fields, magnetars are in a class of their own due to their unparalleled strength. They are, without question, the undisputed champions of magnetism throughout the known universe. What does this immense power mean for the space immediately surrounding a magnetar? If you imagine yourself in a park, feeling a strong breeze, you can see it move leaves and branches. Near a magnetar, however, the effect is infinitely more dramatic. Charged particles in its vicinity are seized and accelerated to nearly the speed of light, which not only results in spectacular visual phenomena, but also generates intense X-ray and gamma-ray emissions that are detectable from thousands of light-years away. The energy that a magnetar can discharge is so staggering that it rivals cosmic explosions, with some of its bursts being powerful enough to be observed here on Earth. Thankfully, these objects are so far away that their cataclysmic releases pose no direct danger to us. However, were a magnetar situated closer to our solar system, its radiation would be hazardous and could even prove devastating for our planet's survival. The mechanism by which a magnetar generates this extraordinary magnetic field is a subject of intense fascination. It's believed that the field originates from the object's incredibly fast rotation, combined with the immense pressure in its core. As it spins, the magnetar essentially functions as a gigantic dynamo, creating a magnetic field that appears to defy all conventional logic. This might sound like something out of science fiction, but it is simply physics operating at its most extreme. Beyond their magnetic fields, magnetars hold other mysteries, such as what occurs when they start to lose energy. Over time, their magnetic field is expected to weaken, which in turn alters their behavior and signals the end of their life cycle. Astronomically speaking, a magnetar's existence is quite brief, lasting only a few thousand years before its tremendous energy finally subsides. Given the sheer number of stars in our galaxy, the population of magnetars is incredibly small, making them exceptionally rare and special celestial objects. This scarcity is precisely what makes them so compelling to astronomers and scientists who are trying to solve the universe's greatest puzzles. Each one stands as a stark reminder of the absolute extremes that nature is capable of achieving. There are even speculative theories suggesting a magnetar's magnetic field could be potent enough to directly influence the behavior of matter in its galactic neighborhood. This possibility raises profound questions about how these objects might impact the formation of nearby stars and planetary systems. It's possible they hold the key to understanding certain astrophysical phenomena that remain completely unexplained. The investigation of magnetars has propelled modern astrophysics forward in significant ways, as each discovery about their extreme magnetic fields brings us a step closer to deciphering the fundamental mysteries of the cosmos. So the next time you find yourself looking up at the sky, wondering about the secrets it holds, remember that somewhere in the distance, magnetars are spinning, creating forces that challenge our very imagination. Exploring these objects doesn't just expand our cosmic knowledge. It helps us better understand the nature of reality itself. Science is in a constant state of flux, and each new revelation about magnetars serves as a reminder that our universe is a place brimming with surprises yet to be discovered. These objects are a peculiar class of neutron star, but were you aware that not all magnetars are identical? A compelling classification system actually exists that allows us to gain a deeper understanding of their properties and behaviors. And the variety among these celestial bodies is so profound that every single one has a unique story to share. First, I want to explore rotating magnetars, which are the most widely recognized type. Just as their name implies, they spin at high speeds around their own axis. If you picture a spinning top, you know that the faster it turns, the more energy it possesses. This very same principle is at work with these magnetars. Their phenomenal rotation generates a staggering amount of energy, leading to bursts of X-rays and gamma rays so powerful they can be detected from millions of light years away, possessing an energy output rivaling that of several million suns combined. A truly magnificent cosmic display. In contrast, we have magnetars that are characterized by their overpowering magnetic fields. While these are also neutron stars, their most defining attribute is the immense magnetic field they generate. This field is so potent that it can actually bend space and time in their vicinity, much like a colossal magnet pulling everything into its influence. Can you even conceive of a magnetic field with the strength to change the course of other celestial objects? It's a genuine marvel of the cosmos. The system for classifying magnetars is founded on their observed behavior and physical characteristics, but there are additional factors that contribute to this categorization. For instance, a magnetar's chemical makeup can dictate how its defining traits are expressed. Some might possess a denser core, which in turn can influence both their magnetic field and the manner in which they release radiation. It's almost as if every magnetar has a distinct personality, molded by the circumstances of its birth and subsequent evolution. Another critical element in this classification is the length of their activity cycles. Certain magnetars can lie dormant for many years, whereas others exhibit much more frequent and violent eruptions. This inconsistency provides us with valuable clues about the internal mechanisms at play within these cosmic bodies. and it raises fascinating questions about how their behavior unfolds over vast stretches of time. What are the triggers that cause a magnetar to awaken and unleash its stored energy? Here is a compelling detail for you. Rotating magnetars typically appear to be younger than their magnetic field-dominant counterparts. The reason for this is that their swift rotation causes them to expend their energy more rapidly, effectively cutting their lifespan short. But what occurs when a rotating magnetar transitions into a magnetic one? This changeover remains an enigma that astrophysicists are actively working to unravel, as it could yield crucial information about the life cycles of these massive stars. Furthermore, magnetars can display varied types of emissions based on their specific classification. Rotating magnetars are known to emit regular, predictable pulses of X-rays, whereas magnetic magnetars can have far more erratic and unforeseeable discharges. This variation in their emissions can offer deep insights into their internal architecture and the dynamics governing their magnetic fields. Every flash of light we witness from Earth could be a message sent from the distant past of these incredible objects. My curiosity, and hopefully yours, doesn't stop there. As we probe deeper into the study of magnetars, it becomes apparent that their classification can also shape their influence on the space around them. A rotating magnetar with intense activity, for example, could exert a significantly more profound effect on its environment than a comparatively placid magnetic magnetar. Just think about how these cosmic events might impact nearby stars and planets, potentially influencing the formation of new solar systems or altering the dynamics of an entire stellar neighborhood. As researchers persist in classifying and examining these captivating objects, it's increasingly evident that every magnetar represents a unique cosmic enigma. The classification system not only aids our comprehension of their features, but also paves the way for new lines of inquiry. What other categories of magnetars could be out there? Might there be variations that we have yet to find? It is the pursuit of these mysteries that propels the entire field of astrophysical research forward. Ultimately, classifying magnetars is more than just an academic pursuit. It's a profound method of connecting our species with the greater cosmos. It stands as a powerful reminder that while we may inhabit a tiny corner of the universe, there are extraordinary phenomena that compel us to continue exploring, learning, and feeling a sense of wonder. Each magnetar is a narrative waiting to be told, and we have become the chroniclers of this grand cosmic epic. So, the next time you gaze up at the night sky and ponder the stars, I want you to remember that among them are these magnetic titans, the magnetars, which teach us about the very limits of the universe and the incredible diversity it holds. Classifying these celestial bodies isn't merely a technicality. It is an essential key for unlocking the secrets of the cosmos. With every new observation and subsequent classification, we move one step closer to grasping the immense beauty and complexity of the universe we call home. The emission of X-rays and gamma rays from magnetars is a spectacular phenomenon that has thoroughly captivated astronomers and scientists across the globe. But what does this really signify? To get a clear picture, you must first recall that magnetars are neutron stars, defined by their extraordinarily powerful magnetic fields, a fact that directly governs how they emit radiation. Across the boundless expanse of the universe, these emissions act like brilliant beacons at a cosmic celebration, lighting up the void and telling us stories about matter in its most extreme forms. I want you to try to picture yourself standing in a pitch-black room. Then, without warning, someone activates a high-powered laser that slices through the darkness, painting the space with dazzling patterns of light. This is fundamentally how magnetars operate, except instead of a simple laser, they are unleashing X-rays and gamma rays, two incredibly high-energy forms of radiation. The pressing questions then become, how do we even know they exist? And what methods do we use to detect them? The key to understanding these phenomena rests with our space telescopes, which serve as immense cosmic eyes, extending our vision far beyond human limits. Telescopes like Chandra and Fermi are specifically engineered to detect these unique emissions. When a magnetar unleashes its energy, it projects bursts of gamma rays thousands of times more potent than any other source in the cosmos. These incredible flashes are so powerful they can be perceived from millions of light years away, enabling us to investigate these events even from our own quiet nook within the galaxy. You might be wondering what causes a magnetar to radiate X-rays and gamma rays at all. The explanation is found in the sheer instability of its magnetic field, which is so powerful that it triggers colossal releases of energy. These events manifest as brilliant, though often short-lived and incredibly forceful, explosions. Every time one of these outbursts happens, it is like the magnetar is broadcasting a signal across the universe. A message that provides us with invaluable data, deepening our comprehension of matter's fundamental nature and the universal forces that shape everything. Furthermore, these eruptions are not one-off occurrences. They follow a cyclical pattern where a magnetar can remain dormant for a period before suddenly unleashing a tremendous amount of energy. This erratic nature adds yet another level of complexity to their study, compelling scientists to develop models to predict their timing and cause. This work is comparable to forecasting weather, except the storms we're dealing with are made of cosmic energy. The existence of magnetars also serves as a profound reminder of our own scale in comparison to the universe. A solitary gamma-ray burst from one of these objects can unleash more energy than our sun will generate over its whole lifespan. Contemplating this staggering power compels us to reevaluate our foundational understanding of physics and astrophysics, leaving you to wonder what other secrets lie concealed in the vastness of space, awaiting discovery. Speaking of secrets, some researchers propose that magnetars might hold the solution to even more baffling phenomena, such as the gamma-ray bursts we detect from Earth, suggesting these cataclysmic events could be a direct result of magnetar activity. Through the careful study of their emissions, we have a chance to unlock the enigma behind these powerful events. This process is akin to assembling a cosmic jigsaw puzzle, where with every piece we fit into place, the grander image of the universe becomes clearer. As our investigation into magnetars deepens, we start uncovering links to other astrophysical occurrences. For instance, theories suggest magnetars could be connected to the development of specific kinds of galaxies. This indicates that the impact of these neutron stars reaches far beyond their immediate presence, as they are intrinsically woven into the very structure of the universe. A thrilling prospect of this research is how magnetars might advance our knowledge of fundamental physics. The extreme environments these objects harbor could offer vital clues about the operation of universal forces. In essence, magnetars function as natural laboratories, giving us a unique opportunity to probe the very limits of physical laws. However, not all emissions from magnetars are destructive. They can also spur technological progress. Research into X-ray and gamma-ray radiation might inspire medical innovations, including the creation of more advanced imaging technologies. Consequently, something that appears so remote and disconnected from our daily lives could have tangible applications that affect us directly. Ultimately, you should remember that each emission of X-rays or gamma rays from a magnetar is a signal sent out into the cosmos, an echo of its existence, like a lighthouse in the cosmic dark. Every flash we detect serves as a reminder that the universe holds far more than we can perceive or comprehend, and each new finding inches us closer to solving its deepest secrets. So, the next occasion you find yourself gazing at the night sky, recall the immense and enigmatic forces operating out there. Magnetars, with their potent X-ray and gamma-ray bursts, represent just one of countless marvels that beckon us to keep investigating the vast, mysterious cosmos we inhabit. While magnetars are undeniably captivating, their impact extends far beyond themselves. Picture a drum that, when beaten, doesn't just make a noise but also sends out vibrations that alter its surroundings. This analogy captures how magnetars engage with the space around them. A magnetar's magnetic field is so immense that its influence extends to other stars and even to the fabric of space-time itself. When a magnetar is situated near other stars, its very presence can change their paths through the cosmos. If you visualize a magnetar as a colossal magnet, you can grasp how its force might either pull in or push away nearby stars and interstellar material. Now, consider the fate of planets that happen to be orbiting a magnetar. The intense radiation these objects pour out would be absolutely ruinous, leading to disastrous outcomes. Magnetars expel enormous quantities of energy as X-rays and gamma rays, which shoot through space like projectiles in a cosmic sea. Upon reaching other stars or planets, this radiation can transform their atmospheres and even their fundamental structures. Could you even conceive of life existing on a world orbiting a magnetar? The sheer intensity of the radiation would almost certainly make life as we understand it completely unviable. Central to this powerful interaction is the spectacle of gamma-ray bursts, tremendous explosions of light, often linked to magnetars, that light up the entire universe. The amount of energy liberated during these bursts is truly beyond imagination, allowing them to be observed from billions of light-years across space. If a planet were nearby, the effect of such a blast would be catastrophic changes to its surface. And moreover, the close presence of a magnetar can even shape the development of entirely new star systems in its vicinity. Among the universe's most captivating phenomena are neutron stars. But you might wonder what they truly are. Picture a colossal star reaching the end of its existence and erupting in a supernova, which unleashes a staggering quantity of energy. The aftermath of this cosmic blast leaves behind a collapsed, compact star whose material is compressed to an unbelievable density, so extreme that a single teaspoonful would possess the weight of an entire mountain. So, what are the specific traits that make neutron stars so extraordinary? To grasp this, you first have to consider what they're made of. Their substance is composed almost entirely of neutrons, which are subatomic particles that carry no electrical charge. You can think of neutrons as the quiet but immensely powerful counterparts to protons and electrons. And it's this composition that gives neutron stars their status as one of the densest structures in the entire cosmos. Another fascinating quality of neutron stars is their sheer size. Even though they contain a mass similar to our own sun, their diameter measures only about 20 kilometers. To help you visualize this, picture an object the size of a major city that holds the weight of a massive star. This incredible compression generates an immense gravitational field, with a force at its surface many times stronger than Earth's, capable of instantly pulverizing anything that falls onto it. So, what is the connection between neutron stars and magnetars? While both are born from the collapse of giant stars, a crucial distinction sets them apart. Magnetars represent a unique category of neutron star, one that features not only immense density, but also an exceptionally potent magnetic field, millions of times more powerful than an average neutron star. This magnetic force is so extreme that it can manipulate nearby matter, producing some of the most captivating phenomena in the cosmos. The creation of a neutron star, and by extension a magnetar, happens as a massive star concludes its life. Once the star has depleted its nuclear fuel, its own gravity becomes overwhelming, and it can no longer support itself. This gravitational failure sets off a tremendous explosion called a supernova, leaving behind a stellar remnant that has been compressed to a remarkably small size. Yet not every neutron star evolves into a magnetar. This transformation only happens under precise conditions that amplify its magnetic field during the collapse. You might ask why it's so crucial for us to investigate these objects. By figuring out how they are formed and what sets them apart from other celestial bodies, we can begin to unlock the universe's greatest secrets. Neutron stars, and especially magnetars, serve as cosmic laboratories where we can observe physics operating in extreme states that are impossible to reproduce on our planet. The insights gained have significant ramifications for our grasp of fundamental physics, matter, and gravity. Furthermore, examining neutron stars offers you a window into the future of the cosmos, prompting questions about the ultimate fate of the stars within our own solar system. Critically, it forces us to contemplate the potential effects that these bizarre and potent objects could have on life on our own world. Should a magnetar ever wander too close to Earth, the outcome would undoubtedly be catastrophic. Thanks to their immense gravitational pull, magnetars can draw in surrounding gas and cosmic dust, fostering environments ripe for the formation of new stars. So, could one of these objects actually catalyze the creation of entire constellations? Intriguingly, the answer is yes, provided the right conditions are met. The sheer energy they radiate might even influence dark matter and dark energy, those mysterious elements of the cosmos that continue to elude our complete understanding. This potential interaction holds the promise of unlocking fundamental clues about the universe's very fabric. Imagine the secrets we could uncover if we deciphered how magnetars engage with these unseen cosmic components. Every magnetar is one of a kind, leaving a distinct signature on its environment. While some release energy in predictable rhythmic pulses, others act far more erratically, and this variation dictates how other cosmic bodies react to their presence. Is it possible that magnetars function as cosmic beacons, directing the movement of other objects in their vicinity? In a larger context, their very existence serves as a potent reminder of the profound interconnectedness of our universe. Much like a stone tossed into a pond sends ripples across the water, a magnetar's presence can trigger consequences for innumerable cosmic events. Comprehending these ripple effects could give us a completely new way of looking at how the cosmos operates on the grandest scale. Each new discovery related to magnetars compels us to re-examine our existing scientific models. Probing how they impact their surroundings has the potential to unlock entirely new pathways for comprehending other astrophysical events. You can't help but wonder what further surprises these exceptional stars have in store for the astrophysicists who study them. Moreover, a magnetar's reach is not confined merely to physical space. It also has the power to alter radio waves and different types of radiation that travel from the cosmos to our own planet. These powerful cosmic broadcasts can function as a unique window into the unknown, unveiling universal secrets that would otherwise stay concealed from us. The existence we know is intricately woven into the fabric of our environment, and magnetars serve as a powerful reminder that forces exist far beyond our command. Witnessing how these extreme celestial bodies influence their surroundings and their cosmic neighbors encourages a deeper reflection on our own small part in this vast universe. You can conceptualize magnetars as cosmic titans, whose deeds echo through space and time itself, forging a cosmic ecosystem that stretches far beyond our line of sight. This makes you question just how many marvels and secrets remain hidden in the limitless universe, simply waiting for us to find them. The answers are found in our own curiosity and our innate drive to venture into the unknown. So, the next time you gaze up at the night sky, I want you to remember that each star, every cosmic event, and every single magnetar has a unique story to share. These celestial objects are more than just captivating spectacles. They are crucial pieces in the grand puzzle of the universe. Investigating their effects on the space around them is merely the start of a much greater expedition toward a more profound comprehension of the cosmos itself. The relationship between neutron stars and magnetars invites us to contemplate the sheer variety found within the cosmos. Across the immense expanse of the universe, each celestial body possesses a distinct narrative and singular traits. The incredible density and extraordinary properties of neutron stars serve as a potent reminder of just how little we comprehend about the cosmos, as every fresh discovery prompts new questions, fueling our innate curiosity and our drive to understand more. Ultimately, neutron stars are much more than mere remnants of expired stars. They function as intricate entities that provide a glimpse into the physics of the universe at its most extreme. With every new finding, astronomers inch closer to deciphering not only these bizarre stars, but also the fundamental nature of reality itself. The investigation into neutron stars and magnetars represents a journey that has only just commenced, and each breakthrough holds the potential to reshape our perception of what is possible in the universe. Following this train of thought, it's remarkable to consider how these stars, for all their distance and extreme characteristics, are deeply connected to the history of our own planet. The quest for knowledge about neutron stars is, in essence, a search for our own place within this vast cosmic tapestry. Have you ever encountered the term pulsar and contemplated how it is distinct from a magnetar? Although both are varieties of neutron stars, a number of fascinating differences distinguish them. Let's begin by clarifying what exactly a pulsar is. You can envision a pulsar as a neutron star that functions like a celestial lighthouse, emitting beams of electromagnetic radiation into the vast ocean of space at regular intervals. Magnetars, conversely, represent a special category of neutron star, set apart by one defining feature: an incredibly powerful magnetic field that is orders of magnitude stronger than a pulsar's. Just try to picture a magnet with enough force to influence everything that approaches it across unimaginable distances. This is the true power of a magnetar. To be more specific, its magnetic field can be 1,000,000 billion times more intense than that of a typical magnet, which is comparable to the strength of 1,000,000 of Earth's magnetic fields combined. But how does this profound difference show up in their activity? While pulsars rotate and radiate with clockwork regularity, producing a rhythmic pattern we can measure, magnetars are significantly more erratic, with emissions that can be explosive and chaotic, almost like a volcano erupting without warning. This volatility occurs because the extreme conditions within their cores cause their energy to be unleashed unpredictably, often in massive bursts of X-ray or gamma radiation. You might wonder why these distinctions are so significant. Gaining insight into how magnetars and pulsars function allows us to solve some of the deepest mysteries of the universe. For instance, scientists use pulsars as cosmic clocks due to the remarkable precision of their signals, while magnetars and their intense magnetic fields serve as natural laboratories for exploring physics under conditions we could never replicate on Earth. The lifespans of these objects also differ quite dramatically. Magnetars are thought to have a much shorter existence, typically lasting only a few thousand years, in contrast to pulsars, which can survive for millions of years. This is because their energy is depleted so rapidly, especially when they unleash those powerful bursts of radiation. So, while a pulsar might continue its steady blinking for eons, a magnetar's life cycle is shorter, but certainly no less spectacular. When you consider magnetars and pulsars, it is helpful to remember that they belong to the same cosmic family but exhibit very different behaviors. Pulsars are the stable and predictable members, whereas magnetars are the volatile and explosive ones. This very diversity in the nature of neutron stars gives us a more complete picture of stellar life cycles and the processes that shape the universe. A magnetar's influence extends beyond itself, as its immense magnetic field can dramatically alter the space around it, potentially deflecting the path of light or even affecting the movement of other nearby stars. This quality makes their study exceptionally important for understanding the dynamics of the cosmos on a grander scale. This comparison also prompts us to consider their respective roles in the evolution of galaxies. You could think of pulsars as beacons that illuminate the darkness of space, while magnetars might be seen as brilliant fireworks that explode across the sky, leaving a trail of energy that can be detected over vast distances. Ultimately, while magnetars and pulsars are both captivating and strange, their differences speak to the incredible diversity of the universe. Each, in its own fashion, tells a story about physics, energy, and the cosmic forces that have shaped our existence. The lifespan of a magnetar remains one of those fascinating enigmas that continues to challenge scientists. How long does one of these objects actually live before its powerful magnetic field begins to fade? The answer isn't simple, but we can use the analogy of a lighthouse caught in a storm. A lighthouse can shine its beam with great intensity, guiding ships to safety, but its light will inevitably dim if it isn't refueled. Similarly, magnetars, despite being among the most mysterious objects in the universe, also have a limited active lifespan. It is generally thought that a magnetar's life lasts for about 10,000 to 1 million years, a span that seems immense by human standards, but is merely a fleeting moment in the cosmic timescale. The explanation is rooted in the inherent instability and internal dynamics of these remarkable stars. Throughout its existence, a magnetar can undergo a series of gamma-ray bursts, which are spectacular cosmic eruptions that unleash a tremendous amount of energy in a mere moment. Each of these flashes, however, signals that the magnetar is gradually exhausting its energy reserves, fading slowly like a bright light, and becoming weaker as it approaches its eventual demise. The profound magnetization of a magnetar produces a fascinating effect on its cosmic vicinity. As its powerful magnetic field decays, phenomena like radiation emissions take place, which in turn begin to alter the star's immediate surroundings. This can trigger a cascade of interactions that impact not just the magnetar itself, but also any celestial bodies caught in its orbit, demonstrating how its life influences the fate of other objects in the cosmos. Magnetars are often likened to the superstars among neutron stars. Their lifespans are remarkably brief compared to other stellar bodies. Yet during this short time, they can unleash more energy than millions of our galaxy stars combined. While every magnetar is a brilliant display of light and power, its energy eventually wanes, much like a grand performance reaching its conclusion, which leads to a compelling question. What exactly occurs when a magnetar finally goes dark? One of the most prevalent theories posits that at the end of its active life, a magnetar may transition into a standard neutron star. This transformation is not an instantaneous event. Rather, the magnetar enters a protracted cooling phase where its magnetic field weakens and its activity steadily declines. This cooling stage can span thousands of years, at the end of which the star settles into a more inert and quiescent state in space. Nevertheless, the question of what happens after a magnetar fades remains a captivating subject of research. Some scientists theorize that these objects could leave behind remnants detectable for millennia, speculating that some of the neutron stars we observe today might be the dead relics of once luminous magnetars. Another perplexing question is whether a magnetar can reignite after its energy has been depleted, a possibility that, while suggested by some researchers under specific conditions, remains a deeply mysterious and poorly understood field of study. Within the scientific community, a magnetar's lifespan holds significance beyond the object itself, offering wider insights into the evolution of massive stars and their role in the creation of new star systems. By examining how and when magnetars die, astronomers gain a clearer understanding of stellar life cycles and their influence on the universe. Therefore, even though a magnetar's life is fleeting, it serves as a powerful lesson about the fundamental nature of the cosmos, with each one telling a story of creation, immense energy, and eventual disappearance. So, the next time you gaze up at the night sky, you can reflect on the fact that while magnetars are remote and enigmatic entities, their life and death are integral to the cosmic cycle that continuously shapes our universe. Deep within the immense expanse of our Milky Way galaxy, these mysterious objects exist, constantly challenging our comprehension of the cosmos. But the question of how many of them truly reside in our galaxy is not as straightforward as you might think. Astronomers have currently confirmed the existence of about 24 magnetars within the Milky Way. There is, however, the thrilling prospect that countless more could be lurking, concealed within the vast sea of stars and dark matter that envelops us. Picture yourself on a shoreline where each incoming wave symbolizes a star. Most are like familiar, distant lighthouses, but a few of these waves are uniquely different. These are the magnetars, each with its own history, yet all born from the cataclysmic explosions of supernovae. The placement of magnetars throughout our galaxy is anything but arbitrary. They are predominantly located in regions of vigorous stellar activity, like young clusters where stars are born and perish in rapid succession. Understanding their locations is crucial because of the profound effects they exert on their surroundings. The extreme gravity and magnetic fields of magnetars can alter the paths of other stars and even shape the formation of entirely new star systems. What's particularly fascinating is that while we have a limited number of confirmed magnetars, scientific estimates suggest there could be hundreds more scattered across our galaxy. This discrepancy exists because many are likely too faint for our current telescopes to detect. It's akin to being at a huge gathering in a dimly lit room. You can clearly see some of the guests, but many others may be hidden in the shadows, awaiting discovery. Observing these celestial objects is a formidable challenge, as their visible light is often weak and faint. Although their X-ray and gamma-ray emissions are incredibly powerful, they can be quite difficult to capture. To overcome this, astronomers employ advanced technologies like space-based telescopes to hunt for these faint signals. The process resembles fishing in a vast ocean. The line might often feel slack, but with persistence and the right equipment, you could reel in something truly extraordinary. As scientists persist in their exploration of the Milky Way, they are gradually piecing together how magnetars are distributed. Observations reveal that they tend to be more concentrated in the densest galactic regions, where gravitational interactions are more common. This grants them a distinctive role in the cosmic tapestry, where they act as luminous markers that shed light on the history of star formation and open up new inquiries into their origins, such as whether different families of magnetars could arise from various types of supernovae. Picture a celestial genealogy where every magnetar represents a unique lineage, narrating the chronicle of its own genesis. These objects are captivating not just due to their prevalence and location, but also because of the profound impact they exert on their environment. The immense magnetic fields they generate can alter the development of neighboring stars, shaping their formation and ultimate fate, thereby fostering a vibrant and constantly shifting cosmic community that has captured the intense focus of astronomers. Investigating magnetars provides scientists with deeper insights into the complete life cycle of stars. Every new finding concerning a magnetar sparks further inquiries into the processes of stellar birth, existence, and demise within our galaxy. You can think of it as a grand cosmic enigma, where each uncovered component holds a much deeper meaning than it first appears. The quest to find magnetars carries significance that extends far beyond the confines of our own galaxy. By analyzing their distribution pattern within the Milky Way, astronomers are able to deduce the likely presence of these objects in other galaxies. Such findings aid in uncovering the underlying principles of galactic formation and the broader evolution of the cosmos, effectively giving us a glimpse into the universe's distant history. Ultimately, the compelling puzzle of magnetars within our galaxy serves as a potent reminder of how much remains unknown about the universe. Each breakthrough prompts new lines of investigation, and with every solution, we move nearer to deciphering cosmic secrets. As our search persists, you'll see that each magnetar we locate acts as a source of enlightenment, shedding light on its own story and, in turn, our place within this immense expanse. So, how is it possible to identify an object as remote and enigmatic as a magnetar? The solution lies at the intersection of remarkable technology and relentless scientific inquiry. Because of their powerful magnetic fields and emissions of X-rays and gamma rays, magnetars are notoriously difficult to see directly. Nevertheless, astronomers have devised incredibly clever techniques to observe and analyze them. Observing X-ray emissions is the primary instrument in this voyage of discovery. Picture yourself standing in a pitch-black space when a brilliant flashlight is suddenly activated. The scattered light would expose details previously hidden from your sight. In a similar fashion, magnetars radiate X-rays that, when collected by purpose-built telescopes, supply crucial data about their fundamental properties. You can think of these telescopes as colossal celestial eyes, able to perceive radiation entirely invisible to human vision. Now consider what occurs when a magnetar unleashes a sudden eruption of energy, as this provides another critical method for their identification. The power emitted in these occurrences can rival the output of billions of suns combined. These outbursts appear as brilliant flashes in the gamma-ray spectrum, much like a distant lighthouse beacon. Observatories designed for gamma-ray detection, like the Fermi Space Telescope, are able to record these events, enabling scientists to examine the conduct of these captivating celestial bodies. The analysis of radio waves is another essential component in the detection of magnetars. If you think about the way sound propagates through the atmosphere, radio waves function similarly, only they traverse the vacuum of space. A rotating magnetar can discharge regular pulses of radio waves, which behave like a spinning beacon. Ground-based radio telescopes can intercept these pulses, providing us with further data regarding the magnetar's spin rate and magnetic field strength. While they are not the main instruments used for this purpose, optical telescopes still have a role to play in magnetar research. Even though a magnetar's immense radiation obscures most visible light, some telescopes manage to capture what little light gets through. This capability allows astronomers to study the magnetar's immediate vicinity and its interactions with the surrounding area, which offers important context for understanding its origins and attributes. Achieving a comprehensive understanding requires close collaboration between various kinds of telescopes. Scientists can construct a much more detailed model of the activity at a magnetar's core by integrating data from X-ray, gamma-ray, and radio observations. You can compare this process to solving a complex puzzle made of differently colored and shaped components, where every single piece contributes distinct information needed to form the final picture. As our technological capabilities progress, the methods for detection grow ever more refined. For instance, Earth-orbiting satellites now carry instruments that can register high-energy radiation, which permits live observation of celestial events as they unfold. This development has fundamentally altered how we investigate magnetars, greatly enhancing our awareness of their behavior and their influence on the universe. You might ask why it is so critical to research these objects. The reason is rooted in the profound effect magnetars have on our comprehension of the cosmos. Through the examination of their characteristics, we can gain knowledge about the laws of extreme physics that dictate how matter behaves in environments that are impossible for us to recreate here on Earth. So, what part do scientists play in all of this? You can see them as contemporary adventurers who use technology for navigation and data as their charts. Every fresh observation represents a new expedition into uncharted territory, where they unearth the secrets of the universe and then present their findings to humanity. This relentless drive for discovery fuels their efforts, and each magnetar they analyze becomes one more solved piece in the immense cosmic jigsaw. The establishment of cooperative networks that link scientists across various institutions and nations has also greatly aided magnetar research. Researchers can expedite their findings by pooling data and resources, allowing them to benefit from one another's specialized knowledge. This collaborative ethos is vital for advancing the field of astrophysics and serves as a reminder that even with the vast distances of space between us, our shared pursuit of knowledge connects us all. Peering into the future, it becomes evident that the methods for detecting and studying magnetars are set to keep advancing. Emerging technologies, including more potent telescopes and next-generation satellites, hold the promise of significantly expanding our comprehension. Every novel achievement moves us another step closer to unlocking the enigmas of these cryptic objects and fully understanding their significance in the grand narrative of the cosmos. Within the immense expanse of astrophysics, magnetars stand out as genuine cosmic marvels that defy our current comprehension and provoke new lines of inquiry. You might ask why they are so crucial for studying the cosmos. The answer is found in their truly exceptional characteristics. While magnetars are a category of neutron star, they are distinguished by their incredibly potent magnetic fields and powerful emissions, which have the ability to reveal regions of the universe that would otherwise stay hidden from view. So, what exactly does this signify for the scientific community? In essence, magnetars serve as naturally occurring laboratories where the fundamental laws of physics can be examined under the most extreme conditions imaginable. Consequently, the first major question that presents itself is how these objects reshape our understanding of the universe. As astronomers investigate magnetars, they witness phenomena that are impossible to recreate here on Earth, allowing them to test theories about matter, energy, and the basic forces of nature in a unique environment. Another captivating question is what part magnetars play in the broader evolution of galaxies. The immense energy they radiate doesn't just alter their immediate vicinity. It can also shape the formation of new stars. When a magnetar unleashes a powerful burst of gamma rays, the energy released can disrupt surrounding clouds of gas and dust, potentially setting off the process of stellar creation. This means magnetars are not merely passive subjects of observation, but are, in fact, dynamic participants in the cosmic drama. But how do they connect with other objects throughout the universe? Magnetars represent a vital link in the sequence of events that gives rise to other astronomical phenomena. For instance, it's believed that some of the most powerful gamma-ray bursts are directly tied to magnetar activity. These explosions release an amount of energy that can outshine billions of stars combined. And understanding their origin helps us piece together the universe's most profound mysteries. Despite their vast distance, magnetars have a surprising relevance to our understanding of life here on Earth. Speculation has arisen about the potential effects a nearby gamma-ray burst could have on our planet. Although such an event is highly improbable, the mere possibility that a neighboring magnetar could trigger a life-altering phenomenon serves as a stark reminder of the universe's interconnectedness, making you contemplate the full scope of the wonders and dangers that surround us. Studying magnetars has also yielded incredible insights into matter existing in extreme states. Current theories propose that deep within a magnetar's core, matter behaves in ways we have never witnessed. This prompts us to ask, what secrets are concealed within matter under such intense conditions? Every new piece of information gathered from these objects could have far-reaching consequences for our fundamental understanding of physics. One of the most compelling features of magnetars is their capacity to produce gravitational waves, the faint ripples that travel through space-time itself. These waves provide a completely new method for observing the cosmos, and their detection has launched a revolutionary field in astrophysics. Magnetars are a central part of this new narrative, which leads to the question of what other cosmic secrets might be unlocked by studying the gravitational waves they generate. As scientists pioneer new technologies for observing these celestial objects, they are simultaneously pushing the limits of what we once thought was possible. The combination of advanced telescopes and innovative analytical techniques empowers astronomers to gather data that is more precise and detailed than ever before. This naturally makes you wonder what unforeseen discoveries lie ahead, as our ability to probe the universe continues to advance. Beyond their scientific value, the pursuit of magnetars also cultivates international collaboration among researchers. From coordinating telescopes across the globe to building networks for sharing data, the study of these objects unites brilliant minds from diverse cultures and fields. It's truly remarkable to consider how the investigation of a distant star can bring people together in a common quest for knowledge. Human curiosity is insatiable. Every answer we uncover only seems to generate a fresh set of questions. Magnetars, with their strange and magnificent nature, are a powerful reminder of just how little we truly grasp and how much more there is to explore in the boundless cosmic ocean. With each new breakthrough, we unlock a door to a universe of possibilities, inching closer to comprehending our own place within it all. On a more philosophical level, magnetars compel us to reflect on our own existence. As we learn how these cosmic giants shape their environment and the universe at large, we are forced to confront profound questions about our role in the cosmos. What does it mean to be part of a universe where such extraordinary phenomena can directly influence life itself? This connection shows that while we may be small on a cosmic scale, we are woven into a much grander story. Ultimately, the quest to understand magnetars is a reminder that the universe is perpetually full of surprises. Every pulse they emit tells us that far beyond our own world, there is so much more awaiting discovery. Thus, the search for these objects isn't just a scientific endeavor. It's an adventure that beckons us to look to the stars, question what we observe, and stand in awe of the universe's magnificence. These are some of the most fascinating phenomena in existence. But which ones are the most renowned, and what makes them so unique? Today, I invite you to join me on an expedition to explore some of these cosmic behemoths that push the limits of our physical laws. Our first stop is one of the most famous magnetars, SGR 1806-20, which is situated roughly 1,600 light-years from our planet. Its defining feature is a magnetic field 1,000 times more powerful than a standard pulsar's, a force so immense it could rip apart an object like a car from millions of kilometers away, serving as a potent illustration of how small our world can be against such giants. Next, consider the magnetar known as 1E1048.1-5937, which is remarkable not only for its magnetic intensity, but also for the powerful bursts of X-rays it emits. These eruptions are so energetic that, were they to happen significantly closer, they could prove catastrophic for all forms of life. Thankfully, this object is safely over 10,000 light-years away. But the question of what would happen if a magnetar were nearer is a subject of intense scientific study, as the consequences for life on Earth could be severe. Among the most fascinating magnetars is 4U0142+61, a prime example of how these stellar objects can dramatically shape their surroundings. Its X-ray emissions are not only incredibly potent, but also have the power to influence the formation of adjacent gas and dust clouds. You can picture these cosmic detonations as celestial fireworks that both create a stunning visual spectacle and actively reshape the stellar environment, a phenomenon that continues to captivate astrophysicists. Then there is 1RxSJ170849.024000910, recognized for its puzzling activity and as one of the most closely observed magnetars in our galaxy. This cosmic object has exhibited radiation patterns that defy easy prediction, presenting a genuine enigma for researchers. Although we are not yet certain what drives these behavioral shifts, every new piece of information about its activity moves us closer to a fuller comprehension of these mysterious bodies. It is also essential to mention SGR 1900+14, which has become the focus of many recent investigations due to its extraordinary gamma-ray emissions. These bursts release such immense power that their detection sends ripples of energy across space. You can think of each gamma-ray burst as the pulse of a star's heart, with every beat being recordable from thousands of light-years away, which is not just astonishing, but also provides valuable data about our universe's structure and dynamics. Magnetars are noteworthy not just for their immense energy and explosive nature, but also for the way they challenge our existing scientific models. For instance, the object CXOUJ16471.2-455216 has compelled scientists to reevaluate their concepts of stellar evolution. Its very existence provokes questions about how such objects originate and develop, and whether the universe holds even greater secrets we have yet to uncover. Another magnetar, 1E2259+586, is distinguished by its peculiar conduct. It has displayed fits of activity that can persist for several days, a characteristic that is highly unusual when compared to other magnetars. Researchers are still trying to determine why it possesses such an extended activity cycle, as they work to decode its secrets and understand the behavior of these cosmic titans. Some magnetars, such as PSRJ 1622-4950, are known less for their size and more for the difficulties they pose to observation. Situated in a dense area of our galaxy, this magnetar is exceptionally hard to study directly. However, astronomers have devised clever methods to detect its noticeable influence on the space around it, a true testament to the persistence of scientists in their pursuit of knowledge. We must also acknowledge SGR 0501+4516, which has been analyzed extensively because of its connection to gamma-ray bursts. This object has been instrumental in clarifying how magnetars can initiate such highly energetic events. With each recorded burst, scientists race to gather data that might illuminate the complex mechanisms driving these powerful cosmic eruptions. Our fascination with magnetars also encompasses their discovery over time, as our understanding has grown with advancing technology. Swift J1818.0-1607, for example, was identified quite recently, and its discovery has unlocked new avenues for comprehending the universe. Each new magnetar we locate is like turning a new page in a cosmic story that is still being composed. Finally, it is crucial not to overlook 3XMMJ18524.6.6 plus 003317, which has captured the focus of the research community with its distinctiveness. This object has shown traits that defy our established ideas about magnetars, compelling us to re-examine what we thought we knew. This is the very engine of scientific progress, pushing the frontiers of our knowledge and posing new questions that demand further investigation. These are merely a few examples of the magnetars that populate our galaxy, each possessing its own unique history and characteristics. Investigating them not only deepens our grasp of these extraordinary phenomena, but also provides a clearer view into the fundamental nature of the universe we inhabit. Ultimately, magnetars serve as a constant reminder that the cosmos holds countless discoveries, and every answer we uncover often leads to even more profound questions and adventures. Theories surrounding magnetars offer a captivating maze of ideas that has drawn in both scientists and enthusiasts of space. What is it that truly sets these objects apart? The answer isn't straightforward, which only adds to their allure. At their core, magnetars are neutron stars with magnetic fields of incredible intensity. Yet their origins and the way they function continue to be a profound mystery. One of the most significant questions concerning magnetars is how they attain such immensely powerful magnetic fields. Current theories propose that their extraordinary magnetism is forged during the gravitational collapse of a massive star, as its core implodes to form a neutron star. However, it is not the collapse alone that yields a magnetar. The process requires a set of exceptionally precise conditions to occur. It's theorized that a star's swift rotation, combined with certain dynamo effects, could be crucial elements in the creation of a magnetar. When considering the energy they discharge, it is believed to be on a scale that can actually compete with a supernova. This incredible display of power has driven scientists to investigate exactly how these immense energy bursts are generated. Some researchers proposed that the internal motion of plasma, along with the magnetic field acting almost like an electrical conductor, could be the mechanism behind this massive energy release. Another compelling characteristic of magnetars is their association with gamma-ray bursts. The prevailing theories suggest that magnetars can initiate these powerful events by unleashing the energy pent up in their magnetic fields. You can visualize it as an incredibly tight spring that suddenly breaks, setting off an explosion. This concept illustrates how a magnetar might produce gamma radiation. The behavior of particles within a magnetar's magnetic field also draws significant scientific interest, particularly how these particles influence the radiation that is emitted. The current understanding is that charged particles in the plasma can be propelled to astonishing speeds, which results in the emission of high-energy radiation. This very phenomenon has compelled scientists to explore the physics of these processes more deeply, revealing new horizons in our comprehension of the universe. However, it's important to recognize that not all magnetars are identical, as variations in their characteristics have spawned different theories about their fundamental nature. Some models propose two primary categories of magnetars: one type with more consistent magnetic fields, and another that undergoes significant fluctuations in magnetic intensity. This diversity naturally leads to the fascinating question of what governs this stability. Furthermore, their relatively brief lifespan of perhaps only a few thousand years, a mere moment on the cosmic timescale, makes each observed magnetar a precious window into the life cycle of stars. Beyond this, magnetars have served a vital function in the formulation of new theories in particle physics. You might wonder how such a compact object, relative to its immense power, can offer so many insights about the universe. The solution is that magnetars are essentially natural laboratories, enabling scientists to observe extreme phenomena that are impossible to recreate here on Earth, which has propelled our understanding of physics under the most intense conditions. As new technologies emerge and more sophisticated telescopes are built, we anticipate discovering more magnetars and greatly expanding our theories about them. The possibility of finding types of magnetars we haven't yet detected is truly exciting, as every new observation has the potential to reshape our knowledge of physics and the cosmos. What other secrets might these future discoveries unlock for us? Ultimately, the theories surrounding magnetars also compel us to consider humanity's position in the cosmos and how the existence of these objects shapes our perception of it. Magnetars are remarkable, not just for their physical attributes. They also serve as a profound reminder of how little we truly grasp about the universe and how much more there is to explore. As we continue this journey of discovery, the potential for new knowledge is truly without limit, and these extraordinary objects invite us to keep searching and wondering. Have you ever considered what could happen if a magnetar were located at a threatening proximity to our planet? You should picture a cosmic entity with a magnetic field so potent it could disable the technology we depend on every day. This is not a scenario from science fiction. Magnetars are incredibly dense stars, and although they are light years distant from us, their influence could potentially reach far beyond their present locations. To fully grasp the potential impact a magnetar could have on Earth, you must first understand what it is. As a type of neutron star, a magnetar possesses a magnetic field that can be trillions of times more powerful than our own planets. This fact raises a very serious question. What would occur if a magnetar drifted close enough for its magnetic field to start interacting with Earth? While the chances of this happening are extraordinarily slim, the mere concept introduces a host of both fascinating and alarming possibilities. Imagine for a moment that a magnetar was situated just thousands of light years away from us. In such a case, its magnetic field could disrupt the technologies that are integral to our daily lives. Computers, smartphones, and practically any electronic device could be compromised. Furthermore, satellites in orbit would likely encounter severe malfunctions, triggering widespread outages in our communication and navigation networks. Think about a world where social media vanishes, or where you can't use GPS to navigate your way home. Yet the potential repercussions of a nearby magnetar extend beyond our technology and into the realm of biology. These overwhelming magnetic fields could interfere with the navigation of migratory birds, which rely on Earth's own magnetism to find their way. The resulting disruption to their migration patterns could have unpredictable and cascading effects throughout entire ecosystems. Studies have demonstrated that magnetic fields can alter the behavior of numerous animal species, so a close magnetar could trigger dramatic changes for all life, not just for humans. Finally, the radiation that magnetars emit is a source of major concern. These celestial bodies are notorious for their intense bursts of X-rays and gamma rays. If a magnetar were to approach our world, we could be subjected to levels of radiation that would be catastrophic for life as we know it. This possibility forces us to ask a critical question. Are we adequately protected from these cosmic bombardments? Thankfully, you have our planet's atmosphere and magnetic field serving as a protective barrier. But there would be no guarantees if a magnetar were located in our cosmic neighborhood. We also cannot dismiss the phenomenon of gamma-ray bursts, which are frequently linked to magnetars. These are explosions of almost unimaginable power, and in theory, if one occurred near Earth, it could wreak havoc on our atmosphere, drastically shift the climate, and make life on this planet impossible to sustain. The very concept of a nearby gamma-ray burst is chilling,
Yet it's a reality that astrophysicists investigate to fully grasp its potential consequences.
While these scenarios might sound frightening, they also serve as a powerful reminder of just how insignificant we are in the grand scale of the universe. The vast distances separating us from these cosmic events offer a certain degree of reassurance, but it's crucial for you to remember that the universe is perpetually full of surprises. Each new piece of information we uncover about magnetars and other celestial bodies helps us to more clearly define our own position within the cosmos. So, what does this mean for life here on Earth? Although magnetars are captivating and at times unnerving, it's important for you to realize that their immense distance is what keeps us safe. The truth is that the Milky Way is a tremendously large and mostly uncharted galaxy. Cataclysmic events might seem unavoidable, but the odds of a magnetar having a direct impact on our lives are infinitesimally small. Still, science is in a constant state of progress, and every new investigation into magnetars yields priceless insights. This ongoing research allows us to better prepare our technology and to comprehend the boundaries of our current understanding. As researchers continue to observe magnetars, each discovery has the potential to reshape our perception of how we fit into the universe. As we delve further into the study of these objects, we are also forced to confront the importance of protecting our own world. Our susceptibility to cosmic forces highlights the pressing need to safeguard our environment and brace for any unforeseen events. Science doesn't just provide you with answers, it also equips you with the power to act on the knowledge we gain. Ultimately, even though magnetars may feel remote and irrelevant to your daily existence, their study presents a unique viewpoint on the universe and our place within it. The probability of a magnetar ever affecting Earth remains low, but the lessons they teach us are invaluable. They compel you to look toward the heavens, to challenge what you think you know, and to ready yourself for whatever surprises the cosmos might have waiting. So, what exactly happens when a magnetar flares to life? An incredible event known as a gamma-ray flare takes place, representing one of the most enigmatic and potent displays in the cosmos. But what triggers these outbursts, and what is their true significance for us? First, you need to grasp what these gamma-ray flares actually are. Picture the universe as having a massive light switch. Each time a magnetar unleashes its energy, it's as if a beacon is momentarily switched on, shining with incredible brilliance. In just a few seconds, these flares can discharge more energy than our sun will produce throughout its entire existence. This fact naturally leads you to question how such a powerful event is even possible. The explanation is found within the magnetar's exceptionally strong magnetic field. When the stress in these magnetic fields builds to an unbearable point, it's like a coiled spring at its breaking limit. This pent-up energy is then released in an explosive burst, generating gamma radiation that hurtles through space at very nearly the speed of light. But what does this spectacle mean for the astronomers who are trying to make sense of these occurrences? Scientists employ specialized telescopes designed to pick up on these flares, almost as if they are listening for the reverberation of a cosmic detonation each time a magnetar expels its energy. When this power is unleashed, telescopes register the echoes as light and radiation, enabling scientists to analyze the character of these often brief but staggering events. Now, you might be wondering if these events have any effect on our planet. Fortunately, despite the unbelievable power of these flares, the majority happen so far away that they present no risk to Earth. If a magnetar were situated close to our solar system, however, the results could be catastrophic. An intense blast of radiation could damage our atmosphere and potentially knock out communication systems and orbiting satellites, which makes you consider what might unfold if one of these objects were nearer than we realize. Gamma-ray flares also serve a vital function in helping us piece together the evolution of the universe. With every eruption from a magnetar, you gain new information about how elements are forged in space. It is as if the universe is broadcasting coded signals that scientists are diligently working to decipher. Through the study of these flares, astronomers can learn more about the processes that lead to the formation of stars and planets. Another related occurrence you often hear about is gamma-ray bursts, extremely short and powerful flashes of light that might also be connected to magnetar activity. While magnetars aren't the sole origin of these bursts, studying them has provided a wealth of information. Their connection is that while gamma-ray bursts generally come from immense distances and are linked to the deaths of giant stars, an activated magnetar can create bursts that are shorter but astoundingly potent, adding another fascinating piece to the cosmic jigsaw. Furthermore, you should recognize that gamma-ray flares provide us with a direct look into the realm of high-energy physics. When these flares happen, they transmit data about the fundamental laws that govern the universe. Scientists can observe how matter acts in the most extreme conditions imaginable, which could pave the way for new breakthroughs in fields like physics and astrophysics. As you can see, gamma-ray flares are much more than simple flashes in the night sky. They are profound events that not only illuminate the nature of magnetars, but also the very structure of our universe, bringing us one step closer to solving the cosmic riddles that envelop us. Magnetars are genuinely remarkable, often called the superheroes of neutron stars, and for good reason. Within the field of astrophysics, they present facts that can astound almost anyone. For instance, did you know that in just 1 second, a magnetar can discharge an amount of energy equivalent to what our sun will produce over millions of years? This staggering power isn't merely an impressive statistic. It's a profound reminder of just how potent these celestial objects truly are. Each technological leap forward expands our ability to observe the cosmos in ways that were once unimaginable, delivering answers to questions that previously seemed beyond our grasp. One of the most compelling questions is how we can possibly continue to investigate these phenomena, and the solution is found in the synergy between next-generation telescopes and innovative methods of data analysis. Imagine an orbital telescope engineered to perceive radiation that is completely invisible to the human eye, allowing astronomers to map the sky and expose magnetar emissions that would otherwise stay concealed. In the study of magnetars, computer simulations have also become a critically important tool. These models enable scientists to recreate the extreme environments found in the vicinity of a magnetar, allowing us to see how materials behave under pressures and temperatures that simply don't exist on Earth. This method not only enhances direct observations, but also establishes a theoretical framework for comprehending these objects within the principles of modern physics. Furthermore, magnetars contribute to answering larger questions surrounding the evolution of stars, such as what fate awaits neutron stars that do not develop into magnetars. As this research advances, surprising connections between different kinds of stars and their long-term behaviors are emerging. It's possible that magnetars hold the key to resolving these cosmic puzzles, thereby revealing the complete story of how stars in our galaxy live and die. We should also recognize the significant influence that the search for magnetars has on education and scientific communication. Every new finding about these stars ignites a renewed fascination with astrophysics, motivating new generations of scientists and enthusiasts to turn their eyes to the heavens. It's thrilling to consider that by studying phenomena so far away, we can gain a deeper understanding of our own position in the universe. Another vital component of magnetar research is the spirit of international cooperation. Astronomers from all over the globe collaborate by sharing data and pooling resources, which not only speeds up the rate of discovery, but also cultivates a global community, unified by a shared sense of curiosity. The quest to understand how and why certain cosmic events happen becomes a joint endeavor, with every individual contributing a crucial piece to the overall puzzle. As we look to the future, the prospect of identifying new magnetars continues to excite the scientific community. Finding one much closer to Earth could completely reshape our understanding of how these objects affect their local environments and provide invaluable data on cosmic radiation's impact on our planet. Simultaneously, our theories about how magnetars form are constantly being refined, as each discovery has the potential to challenge our previous assumptions and even lead to entirely new classifications. Ultimately, the search for answers to questions we haven't even conceived of yet is what powers scientific progress. And magnetars may serve as entry points to new fields of inquiry we can't currently imagine. With every new finding, fresh avenues for research appear, holding the promise of unlocking even more of the universe's secrets. It's incredible to contemplate how magnetars might be intertwined with other cosmic processes, perhaps playing a key role in the formation of galaxies or the development of other celestial bodies. Exploring the universe is a journey without end, and magnetars represent just one of the many fascinating waypoints. Human curiosity has always been the engine of discovery, and this particular field of study promises to keep that momentum going strong. The importance of magnetars is defined not just by what we already know, but by everything we have yet to uncover, as each advance in our research could illuminate parts of physics that remain obscure today. So the next time you look up at the night sky, remind yourself that there is far more occurring in the universe than is visible to the naked eye. Gamma-ray flares originating from magnetars are a testament to a cosmos filled with mystery and surprise. As we persist in our exploration, driven by an insatiable curiosity, we are certain to reveal even more about the fabric of reality itself, with magnetars serving as our captivating guides on this grand journey. The magnetic fields surrounding magnetars are so powerful they can physically warp the matter in their vicinity. To give you an idea of their intensity, imagine the gravitational pull being so extreme that if you were to venture too close, your body would be crushed, as if caught in a colossal vice. Can you even conceive of a realm where the very substance of reality behaves in ways that defy all your expectations? A magnetar's life cycle is another element that sets it apart. While you might think of neutron stars as enduring celestial objects, a magnetar can burn through its immense energy in only a handful of thousands of years. That's an incredibly short span, a mere blink of an eye when you compare it to the multi-billion-year lifespan of an ordinary star. What if I suggested that their existence is little more than a fleeting flash in the cosmic darkness? In the field of astrophysics, magnetars are also remarkable for their capacity to produce incredible bursts of X-rays and gamma rays. These emissions are so luminous that our instruments can detect them from millions of light years away. Picture yourself gazing at the night sky and witnessing a sudden flare of light with the brilliance of 1,000 suns combined. Doesn't the significance of this for observers here on Earth seem utterly astounding? The relationship between magnetars and other objects in space is a captivating subject. It is theorized that the intense radiation streaming from a magnetar can directly alter the behavior of charged particles within its sphere of influence. This means a magnetar can orchestrate the movements of nearby electrons and protons, creating a cosmic dance of energy and light. Can you envision being a spectator to a celestial performance that has been unfolding across millions of years? Furthermore, there is a distinct possibility that magnetars do not always exist in isolation. Some scientists propose that they can form binary systems with other neutron stars. What do you think would occur if two such cosmic titans were to collide? An encounter of that nature would likely trigger an unparalleled blast of energy, a genuine cosmic spectacle, capable of briefly outshining entire galaxies. Here's another fascinating detail for you. Despite their awesome power, magnetars are exceptionally uncommon. Within our own Milky Way galaxy, it's estimated that only a few hundred exist. To give you some context, just remember that our galaxy is home to more than 100 billion stars. How is it that objects of such immense power are so incredibly few and far between? If a magnetar were to drift close enough to our solar system, we could find ourselves subjected to radiation levels that would be devastating to all life on Earth. This brings up an important question. Are you and I adequately protected from these cosmic barrages? Fortunately, our planet's atmosphere and magnetic field serve as a vital shield, but they offer no absolute guarantees against a magnetar in our immediate cosmic neighborhood. The occurrence of gamma-ray bursts, which are frequently linked to magnetars, is another phenomenon that we cannot afford to dismiss. These are explosions of almost unimaginable force. If such a burst were to happen near Earth, it could theoretically wreak havoc on our atmosphere, drastically change the global climate, and potentially render our planet uninhabitable. The very thought of a nearby gamma-ray burst is chilling, yet it is a reality that astrophysicists must study to fully grasp its potential consequences. While all of these scenarios might sound alarming, they also serve as a powerful reminder of our own smallness in this immense universe. The sheer distances that lie between us and these cosmic powerhouses afford us a certain degree of safety. However, you and I must never forget that the universe is perpetually filled with surprises. Each new piece of information we gather about magnetars helps us to better comprehend our true place in the grand scheme of things. What does all this mean for life here on our world? Although magnetars are captivating and at times deeply unsettling, it is important to remember that their immense distance is our shield. The truth is that the Milky Way is a vast and mostly uncharted expanse. While cosmic disasters may feel like an inevitability, the statistical chance of a magnetar directly impacting our lives is exceptionally remote. Still, the field of science is in a constant state of evolution, and every new investigation into magnetars yields valuable new perspectives. This knowledge helps us advance our technology and better appreciate the current limitations of our understanding. As researchers continue to probe the mysteries of magnetars, each new finding holds the potential to completely reshape how we perceive our relationship with the universe. As we explore these objects more deeply, we also come to appreciate the profound importance of safeguarding our own planet. Our susceptibility to cosmic events is a stark reminder of the urgent need to protect our environment and prepare ourselves for any unforeseen challenges. Science not only provides us with knowledge, but also gives us the power to act on the insights we gain. Ultimately, even though magnetars might appear remote and disconnected from our day-to-day existence, their study presents a unique window into the universe and our role within it. The probability that a magnetar will ever affect Earth remains low, but the lessons they teach us are beyond measure. They compel us to look toward the heavens, to challenge what we think we know, and to ready ourselves for whatever wonders the cosmos might reveal next. What happens at the moment a magnetar awakens? A breathtaking event known as a gamma-ray flare is unleashed. These occurrences represent some of the most powerful and enigmatic displays in the entire universe. But what is it that triggers these monumental explosions, and what do they truly signify for us? To begin with, you should understand precisely what these gamma-ray flares are. Imagine the cosmos is equipped with a colossal light switch. Each time a magnetar discharges its energy, it's as if that switch is flipped, igniting a beacon that burns with incredible intensity for just a moment. These flares are capable of releasing more energy in a matter of seconds than our own sun will produce throughout its entire existence. This naturally leads you to wonder, how can anything be so powerful? The explanation for this incredible phenomenon is found within the magnetar's extreme magnetic field. When the tension within these magnetic fields builds to an unsustainable level, it's like a coiled spring stretched to its breaking point. This pent-up energy is then liberated in a cataclysmic blast, generating gamma radiation that hurtles through space at almost the speed of light. But what does this mean for the astronomers who are trying to make sense of these events? Scientists use highly specialized telescopes to register these powerful flares. You can picture them as listening for the reverberation of a cosmic detonation every time a magnetar unleashes its energy. Whenever a magnetar lets loose its power, these telescopes are positioned to capture the resulting echoes in the form of light and radiation, giving us a glimpse into one of the universe's most violent acts. These flares, while frequently short-lived, are immensely powerful, offering scientists a unique opportunity to examine their fundamental characteristics. This brings up an intriguing question. Could these cosmic outbursts possibly affect our own world? Fortunately, while the flares are unbelievably potent, the vast majority happen so far away they present no threat to Earth. Yet, if a magnetar existed in proximity to our solar system, the outcome could be catastrophic, as an onslaught of intense radiation could cripple our communication networks and satellites, making you consider the implications if such an object were much nearer. Beyond any potential danger, these gamma-ray flares are also crucial for comprehending the universe's evolution. With each eruption from a magnetar, we receive new insights into how elements are forged in space, as if the cosmos is transmitting encrypted signals for scientists to decipher. Through the analysis of these bursts, astronomers can deepen their knowledge of how stars and planets come into being. A related occurrence often discussed is gamma-ray bursts, exceptionally brief and potent flashes of light that may also be tied to magnetar activity. Although magnetars aren't the sole origin of these bursts, investigating them has yielded priceless data. Typically, these events are linked to the demise of massive stars at immense distances, but when a magnetar becomes active, it can generate bursts that are briefer yet extraordinarily powerful, compelling us to consider where they fit into the grand cosmic scheme. It is also important to recognize that gamma-ray flares give us a direct view into the realm of high-energy physics. During these events, information about the universe's fundamental principles is released, allowing scientists to observe how matter acts in extreme environments. As you can see, these are far more than simple celestial flashes. They are profound occurrences that deepen our comprehension of both magnetars and the essential structure of the cosmos itself. Every finding moves us nearer to solving the cosmic enigmas that envelop us, but there is still so much more to discover about these incredible phenomena. The investigation of magnetars and their gamma-ray emissions is constantly progressing. Each technological leap forward enables us to peer deeper into space than ever imagined. So when you next gaze at the night sky, keep in mind that the universe holds far more activity than is visible to us. Ultimately, the gamma-ray flares linked to magnetars remind us that the cosmos is brimming with mysteries and surprises. These occurrences are the signatures of extreme universal processes, and our continued exploration will surely reveal more about the fundamental nature of reality. It is our innate curiosity that propels this quest for knowledge, and on this journey, magnetars serve as captivating companions. The fascination with these objects certainly doesn't stop with what we already know, as the future of this research is both promising and deeply intriguing. Today's astronomy benefits from state-of-the-art technologies that let us observe distances our ancestors could only dream of. As neutron stars with exceptionally powerful magnetic fields, magnetars are central to lines of inquiry, that have the potential to completely reshape our conception of the universe. A key question is how we can push our investigation of these phenomena even further. And the solution involves integrating advanced telescopes with innovative data analysis. Imagine an orbiting instrument perceiving radiation invisible to our eyes, mapping the cosmos to uncover magnetar emissions that would otherwise go unnoticed. Computer simulations are also indispensable, enabling scientists to model the extreme environments surrounding a magnetar and witness how matter behaves under pressures and temperatures impossible to replicate on Earth. Furthermore, magnetars contribute to answering larger questions surrounding stellar evolution, raising the question of what becomes of neutron stars that don't develop into magnetars. As scientific inquiry advances, surprising links are emerging between various star types and their long-term behavior. It's possible that magnetars possess the crucial information needed to unlock the secrets of how stars are born and die throughout our galaxy. We should also acknowledge the significant influence that this research has on education and public science engagement. Each fresh finding about these stars sparks renewed enthusiasm for astrophysics, motivating a new wave of scientists and hobbyists to turn their gaze upward. It is truly thrilling to consider that by examining such remote phenomena, we gain a clearer perspective on our own position within the cosmos. Global cooperation represents another vital component of magnetar research. Astronomers across the planet collaborate by sharing their findings and equipment, a practice that speeds up the pace of discovery and fosters a worldwide community bound by a shared sense of wonder. This teamwork transforms the investigation into cosmic events into a collective endeavor, where every participant adds a valuable piece to the overall picture. Looking ahead, the prospect of finding more magnetars remains a source of great excitement. Just imagine if we were to locate one much nearer to Earth. Such a discovery could fundamentally alter our comprehension of how these objects affect their local environment. Continued research into magnetars might yield crucial data on cosmic radiation and how it influences not only our planet but life as we know it. While the scientific theories explaining their formation are in a state of constant revision, challenged by every new observation. Magnetars are truly captivating celestial objects, and some of the facts about them in astrophysics are enough to amaze anyone. For instance, did you realize that in a single second, a magnetar can unleash an amount of energy that our own sun produces over the course of millions of years? This staggering power isn't just a number. It's a profound reminder of how formidable these bodies are. They are often called the superheroes of neutron stars, with magnetic fields so potent they can warp the very fabric of matter around them. Can you even comprehend a place where the laws of matter seem to bend in ways you thought impossible? That's the environment around a magnetar, where the gravitational pull is so extreme that if you were to get close, your body would be crushed as if by some invisible cosmic giant. What also sets magnetars apart is their life cycle. While a typical neutron star is incredibly long-lived, a magnetar might burn through its vast energy reserves in only a few thousand years. A fleeting spark in the immense darkness of space compared to the billions of years an ordinary star exists. Within the field of astrophysics, magnetars are also distinguished by their capacity to create massive bursts of X-rays and gamma rays. These emissions are so brilliant that we can detect them from millions of light years across the cosmos. Just try to picture looking up at the night sky and witnessing a sudden flare of light that could outshine 1,000 suns combined. It's truly stunning to consider what such an event signifies for us as observers here on Earth. The way magnetars interact with other celestial bodies is another captivating area of study. The intense radiation they emit is thought to be capable of altering the behavior of charged particles in their immediate vicinity. This means a magnetar can actively influence the movement of surrounding electrons and protons, choreographing a cosmic dance of energy and light.
Can you imagine being able to observe a spectacle that has been unfolding across the galaxy for millions of years? Furthermore, some scientists propose the possibility that magnetars don't always exist in isolation and may form binary systems with other neutron stars. What do you think would occur if two such powerhouses were to collide? Such a merger would likely produce an explosion of energy on an unprecedented scale, a genuine cosmic event that could momentarily light up the entire universe. Yet, for all their incredible might, magnetars are remarkably uncommon. We estimate there are only a few hundred in our entire galaxy. When you compare that to the more than 100 billion stars in the Milky Way, you have to wonder how such potent objects can be so scarce.
This raises the question of whether there could be more varieties of magnetars than we currently recognize. As we continue to uncover more of them, our existing classification systems may require significant updates. This constant evolution is precisely what makes scientific discovery so thrilling, and magnetars are a perfect illustration of this process. The relentless search for answers to questions we haven't even formulated yet is the true engine of science. And these objects might just be the key to unlocking areas of research we can't even begin to conceive of today. With every new finding, fresh pathways for investigation emerge, holding the promise of revealing even more of the universe's secrets. It's incredible to contemplate how magnetars could be tied to other cosmic phenomena. Perhaps future research will show that these objects have a crucial function in the formation of galaxies, or influence the evolution of other celestial bodies. Human curiosity has always been the driving force behind exploration, and the study of magnetars is a field that promises to keep that momentum going strong. Ultimately, the significance of magnetars is found not just in our current knowledge, but also in everything we have yet to learn about them. Each breakthrough in their study has the potential to shed light on areas of physics that are still shrouded in mystery. As we push forward, magnetar research will represent just one of many narratives continuously developing on the vast cosmic stage, challenging our preconceptions and broadening the horizons of what we know. The exploration of the cosmos is a never-ending voyage, and magnetars are one of the most compelling destinations on that path. Who can say what other secrets they conceal, just waiting to be unveiled by inquisitive minds bold enough to pose the right questions? On the frontier of knowledge, magnetars gleam like beacons of the unknown, beckoning us to continue our journey of exploration and discovery as science, and our understanding of what lies beyond our world progresses.